All right. Good afternoon, Jan.
Hi, Michael.
How do you do, sir?
Good. Good. What about you?
Doing very well. Very well. Just trying to find where I put those HTTP test files so I can show something off today. But we'll find them.
Okay. You managed to combine the leaving out the hash numbers and using the bookmarks to do an inverse bookmark.
Getting closer to that. Yes. Yes. Yeah. Um, yeah. So what I have been able to finish is the load method. Um,
Hmm.
so the load endpoint returns a complete fact graph, and it was doing that with a JavaScript or a JSON format. So I have made a serializer to do that with the flat format that we talked about last week. Um, and so it uses the indexes for predecessors rather than hashes, and it doesn't include the hashes at all because they can be computed on the other side. So so that tightens things up a bit. Um, and I was thinking about how to then take that to the feed endpoint and see how we can serialize an entire feed, and then use that idea of the bookmark indicating whether the client has already seen a fact, so that we can
Hmm.
optimize that. So so yeah, ran into to a few problems when trying to reason through that, and so I think I've come up with a solution to those problems, and so we can talk through some of those issues.
Okay. By the way, I just sent you two more remarks on chapter 13 because you were gonna send out the book. I thought to the so I read everything except the core proof, the meat of the chapter,
Uh-huh.
the introduction and the final step I read. Uh, just two small remarks about that. So I send it out already. Um, at least you
Excellent.
have that.
Yeah, thank you.
But the main proof I haven't.
Well,
It's
as it happens, I did find a an issue with the main proof. I It wasn't the issue that I thought that I had spotted. So that's uh, yeah. Maybe we can actually start by talking about that. But but yeah. Before we do that, uh, the reviewer Sander Mack, he mentioned that when it got to the end of the chapter, he's like, I wanted one more. I wanted something to pull it all together. Um, and so yeah, I was noodling on, okay,
mm,
and actually reached out to my editor. Should I add another chapter? Or should I? And
14.
yeah, this is my reasoning. Um, yeah, it's already a bigger book than the first edition, so there's that. But um, I was yeah, I'm for this book. I'm inspired by by basically two books. So Jordan Ellenberg, How Not to Be Wrong. Um, it's a math book. It talks about um, how we convince ourselves of things, and then goes into the sciences and talks about um, the null hypothesis, and the test being that the probability of the null hypothesis explaining this data should be less than 5%, and then it's a meaningful result. Um, from there, you can get into to sigma measurements, but at least p uh, less than zero point zero 0.05 is the starting point. Um, and and so through that book, he's making an argument by just introducing different mathematical concepts. It's like, oh, this is fun, this is nice. And then it was like halfway through reading the book that I realized these are leading somewhere. This important thing that he just said here is based on all of the stuff that he built up. So just the way that he builds an argument, and then he ends the book with some a really important observation about how we conduct science, and some really good recommendations on how we can make things better. It's like, wow, I did not expect such such an important and meaty conclusion out of a recreational math book. Um, but yeah, so that building a narrative thread, building an argument, that was one inspiration to me. And another one was domain-driven design, Eric Evans, the big blue book. And I remember seeing a talk that Eric Evans gave, where he talks about how he should have written DDD. And he says, okay, a lot of people read that first part and they learn how to do, bounded context and repositories, and they say, okay, now I can build a library and I can do that. And that's exactly how I first experienced the book too. It's like, oh, okay, I'm gonna build a library that we can use in our enterprise system. He's like, it wasn't about the library. It was about talking to your stakeholders, creating a ubiquitous language. It was about about doing domain modeling. And he said that was the part that he put at the end. So taking from that, I wanted to make sure that I put the important stuff that I wanted everybody to see as early as possible. And I could get it as early as chapter 6 in the second edition. That's the immutable runtimes. This is how everything could fit together. Before I even tell you how you might build an immutable runtime, I finally get the last piece in chapter 13. But I wanted everybody to see that, and that had the overarching application of an immutable runtime. It showed a full architecture. It showed that architecture evolve. And so it's like, that's the pull it all together chapter, but I put it earlier. So yeah, I was thinking, do I do that again at the end? Or do I just say, go back and reread chapter 6? What I ultimately settled on is that in chapter 6, I had already made reference to Janaga and to immutablearchitecture.com. I think I had the reference in chapter 6, but yeah, chapter 13, just as it ends, it's now going to say, yeah, you can find sample implementations on immutablearchitecture.com. So, yeah, immutablearchitecture.com is going to become the continuation of the book.
Okay.
That's the plan.
So chapter 14 will be...
Yep. Which also means that it will never be finished. I will always be working on it.
Okay.
Yeah. But it's funny, when Sander finished chapter 6, yeah, his last comment there was, yeah, and I was hoping to see, and you can find the reference implementation here, because we built this architecture on in the chapter, but he's like, yeah, now I want to pull that code and run it in Kubernetes and see it work. Like, that's a great idea. Let me do that after the book is published. So yes, that's the reference architecture for the education system that's built up in chapter 6. That will become a runnable thing. You'll be able to deploy replicators using containers and hook them up in Kubernetes and watch them all go.
Okay. No, but I think it's a very nice book, and it goes from chapters which are very easy to understand to chapters which really ask a lot of concentration.
Yes.
And imagination about the models. Where do we go?
Yeah. 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 I tried to make it as accessible as possible, but yeah, there's no getting around that. You have to do the work, put in the time in order to read this book.
Yep.
So let's talk first about that model in chapter. Yeah. was not set up yet this morning. Okay. Okay, so we have here chapter 13 inversion. In fact, I'm going to go back to this view of it. It's a little bit easier to read. That's maybe too big. Control 0. Yeah, okay. All right, so chapter 13, let's look at the kind of the outline of it. It starts here mechanizing the problem with talking about how people do this by hand right now, and if you were to teach something how to do it, then it could make your job easier and then make fewer mistakes. If you have a nice mathematical proof, make no mistakes, as long as your specification is correct. That was one of the points that Sander made, is that, yeah, you've proven the correctness of this inverse, but how do we know that the input was correct? Say, well, I can only do so much. So then it talks about, with a specific problem, how you might break it down. So compute the affected set, which inverses, or which results, which caches, as I call them throughout this chapter, were affected by this new fact, and then targeted updates. What updates do you do? And then it's in computing inverses that it really gets into the meat of the proof.
Yep.
So the very first thing that we do is we talk about tuples again, because they were just introduced in chapter 12. They're very useful for feeds. Well, let's talk about them again here. So if you've got a specification that has a given A, and then it's got a couple of unknowns B and C, maybe you've got a projection. We'll worry about that projection later. We're starting with the body of the specification. That is going to produce a set of tuples, ABC. So we're including the input in that set of tuples. And those are going to be in the set of the types A, B, C. So A is an A, B is a B, C is a C. Capital lower. Yep. So just establishing the mathematical vernacular there. So it's going to be, this outward set notation here is saying I want the set of all such ABC in that set ABC, such that the specification holds and A is equal to a particular fact A0. So that's our goal. That is going to be the resulting products of running that specification with a given A0. So that's going to be what's in a cache. So our goal is to invalidate that cache. So if we were to remove that little extra condition here, this gives you all possible caches. So this is all ABC, and then you could have picked any of these A's to be your given, and you would have gotten a subset. But now I've learned about a new fact, C. We'll say it's Cn is the actual fact that we learned about. And so what I am looking for are the all of the facts, all the tuples with A0, any B, and then Cn. So that tells me that the cache that was built on A0 is now invalid, that there's some result, some new effect. And so I look for the set of all ABC, such that the specification holds, and now I pin it down to where C is equal to Cn. So basically, all I've done to invert this set is to replace one condition, the given A, with another condition, the given C. So now it really just becomes, let's take this set of conditions here, this specification, and rearrange it so that the C ends up in the given and the A ends up down here. How hard could that be? So that kind of sets the 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 tone for what we're trying to do. So these conditions that are inside of these various clauses, and for each one of these unknowns, there's always going to be at least one path condition. That path condition is going to, by convention, start at the unknown that we're inside of, and then end at a prior unknown. So end at the given or end at a prior unknown, so a prior label. The convention is just the order in which those two things happen. So it's always the unknown itself on the left. But even without that convention, it's always got to be relating this fact to some prior unknown. And so that sets up some paths. Those paths define a connected graph. So this isn't the directed acyclic graph of the facts themselves, but this is a connected graph of being able to join one label to another. So if you were to just represent these as the label A, B, C, and you've got an edge between B and A, it's not a directed edge, it's just an edge between B and A, and then between C and B. Then you've got a complete graph. Everything is connected to everything else. Well, not everything to everything else is not a completely connected graph, but it's you can get there by following those edges. So now what we need to do is, given this fact that we've got a connected graph, we can use that to our advantage. Let's demote the given, and now it's got an empty set of conditions on it, so it doesn't have any paths, but the other two do. And then we're going to rearrange things. As we rearrange things, so we pulled, in this case, B above A. Since B has an edge, has a path that joins it back to A, and the paths have to refer back to prior labels, when we swap B for A, we have to reverse this path, make it A to B, and then deposit it inside of A, so taking it out of B. So that's our fundamental operation. Swap two unknowns and move the path from one of them into the other, and swap the equal sign. So if we can do that, then we can end up promoting our top unknown into a given, and we get back to a specification. So that is the fundamental set of operations that we're going to perform, and so the rest of the proof is all the details of how that is always possible, how it continues to produce the same results as the original specification, how to handle all the various conditions. So this was one of the interesting things that I ran into when I was first coming up with this algorithm. So at first, I sketched out a very rough proof, but I didn't have a full proof, and then I unit tested. So let's just come up with examples until something happens. And when I came up with an example that looked like this, then I ran into an infinite loop. So so I have to talk about how this happens and what to do about it. So what happened here is now we're in this previous example we wanted to promote B to the top. In this example we are trying to promote C to the top. So where did it go? It jumped. Okay, there it is. And so as it does so, it deposits its path into B, because C used to have this path in it, but it was the opposite order. So it deposited its path into B and then kept going. It didn't have anything to deposit into A. So now we're left with an empty C and an empty A. And that's not right. We need to make sure that everything is connected to the previous set of unknowns. That condition, by the way, is helpful for turning this into SQL or anything else that's going to execute the specification. So if you just have A hanging out there, so given C, give me all A. Well, you've started with a Cartesian product. And then you say, now give me all B, such that it's related to both A and C. And then your engine has to do a little bit more work to bring that Cartesian product back into step. SQL can do it, but I'd prefer that it didn't have to. So, okay, so you end up with this situation. You'll have two unknowns, or two paths here, no paths there. You want to reorder this graph. So take B, move it above A, and then everything will be fine. So you do that, everything is good. And the tricky detail was precisely how that happens. So this is where my first stab at the at this proof was incorrect. So at first, what I wrote was that you look for anything that has two path conditions, or anything with more than one path condition, and then you keep raising it up until it deposits one of its path conditions, and then you repeat the process, and eventually everything will get flattened out. But that's not true. That actually can give you an infinite loop, where you've got two things that one of them has one path condition, the other one has two, and they're related to each other. It's over-constrained. There are more paths than there need to be. And so you can swap those two, it deposits into this one. Now this one has two, this one has one. Meanwhile, the thing that you really needed to move is further down the graph. There's something else down here that also has two, and it needs to deposit one of its paths further up. But you'll never get there, you'll just keep on swapping these two back and forth. So, so I updated the proof to focus not on the unknowns that have two paths, but instead focus on the unknowns that have no paths. And see what you have to do in order to get this one related to everything that came before. So I kind of broke it down into a head and a tail. So right now C is in the head and A and B are in the tail. The head is connected in such a way that every unknown except for the first one has a path condition. So everything is connected to something earlier in the head. So I can't just put A into the head because that would no longer be true. A is not connected to C. So what I have to do is search through the tail for the first thing that can be moved into the head. So the first thing that has any reference to anything that's in the head. So we're looking at C, and so we look for any path that connects to C. So we find it here. So we promote B, and we put B above A. And now it deposits that path into A, but it still has the path that connects it to C. And so now B becomes part of the head, and you repeat there. So now the head continues to grow, the tail continues to shrink until the tail is gone, and you have something that is properly reordered. So, a valid proof this time. One that guarantees you don't have an infinite loop. And what was really funny, there we go. What was really funny is that as we started this process, Sandra told me, I'm not a mathematician, so I probably won't be able to check the proofs. And he found the infinite loop. And he said, wait a minute. What mean? Does this really mean that it ends? And I said, yeah, you know what? No. So, so yeah, he's a mathematician. So from there it goes on to, well, here's the final one. It says that usually reverses the list of unknowns. It just has to keep finding one, pulling it up. It tends to swap things, swap the order around. But then it goes on to how do you handle existential conditions? So you got the existential condition in there. What happens to that? If it's positive, it just gets promoted to a top level unknown. If it's a negative existential condition, then you end up with a second inverse. So this inverse here, that there exists a CBA, implies that AB is no longer in the cache. So that implication tells you you can remove AB from the cache. And by the way, right here you can see the swapping of order right there. That just naturally happens. How do you handle nested existential conditions? Here I went into more of a concrete example because, like, okay, all of these ABCs getting a little bit hard to follow. Here's an actual example with nested existential conditions, negatives. So delete restore pattern happens all the time. So walks through how you do that, and you end up with, when you see a delete, that implies that you remove the item from the cache. But when you see a restore, that implies this D no longer has an effect, but it does not imply that removing this brings back the item, because it might have been deleted elsewhere. So you have to reapply this nested negative existential condition. So now we end up with D2 and R2 in addition to D and R. So it goes into that detail, and then the child specifications, how we handle these projections with children. I was a bit terse originally with this, and Sanders like, I don't quite get it. Okay, let me expand on that, and showed that here's an example. Back to the generic example of what we mean by this. That your child specification just gives you additional labels, but it's got a subset in common with the parent specification. So that tells us that the projection of that parent contains this product for the child. So then continuing on from there, we talk about how to update the cache. So a bit more expressive this time. This, by the way, is where I thought the error with the proof was. So I thought after writing this and going through it mentally for a little bit, I was like, wait a minute, I'm going to have to update that proof. But nope, as it turns out, this part is actually okay. The error that I thought that I made was that I thought that I didn't have to account for the other positive, the other inverses that would add to the cache. So this inverse right here, whenever you see an item, that item and its menu get added to the cache. Whenever you see a restore, then the restore is related to a deletion, related to an item, related to a menu. So that item and menu get added to the cache. So those are both positive inverses. They both add to the cache. And so what I thought was that the restore had already happened, and so if I see, for example, a menu name, so that's what we were talking about earlier. Well, the specification is way up there, but when we see a new menu name, then we need to update the cache. As I was thinking through it, I thought that that would have been sufficient, and I was doing a lot of extra work. But nope, as it turns out, that is not sufficient. So when I restore the menu name, I do need to continue, or when I change the menu name, I do need to take into consideration the restore. So, yeah, did a bit of clarification around this, but didn't fundamentally change the proof because it was correct. So then just kind of sum it up. So that's a quick run through of the inverses proof and the part of it that I had to change.
I think that's one of the most abstract parts of the whole book.
Yes. Yes, it is. Yeah, I thought that when working on the feeds, I thought this one was going to be the most abstract, but yeah, as it turns out, feeds get just a little bit easier because they stop. They have this extra condition that you can't add something to the middle of a feed, and so that means that you have to stop after one level of negative existential condition, and say, nope, I can't have a negative of a negative because that will, when I see that the assignment was restored, that'll try to add it back to the same feed. So instead I have to make a different feed. So that's why these two are different algorithms, even though they're closely related. And it turns out that feeds is just a little bit easier. So having that come first makes sense. That gives you the tools that then you can use for inversion. Yeah. So yeah. So what's really funny about this is, now that I found this error in the proof, that means that I need to go back to my implementation, both in JavaScript and in .NET, and write tests that would cause an infinite loop for these reasons. For the fact that you have something over-constrained and it ends up with the one that it's seeking hidden down below. So set up those tests, watch it go into an infinite loop, and then I'll implement this algorithm. So kind of what I did with the first edition, and it's like, hey, everything was pipelines, and it's like, no, pipelines are broken, and switched it to specifications.
Yeah. Which is much nicer.
Yeah, I think so.
Much more powerful.
Yes, indeed. Okay, so the next thing that I want to try is, let's see if I can demonstrate the change that I deployed to the replicator as a service. And in fact, this change is also available in Janaga Server. So the let me go back to Postman, because I know I can find it there. And let's see if we can get one of these working. So, yep, here we've got the Janaga blog example. We've got this replicator URL, which is N25E. N25E, yep. This is pointing at the replicator in the cloud. And this is using authentication to get those. So first of all, let's see if this refresh token works. I'll just hit refresh. Ba-ba-ba-ba-bum. This refresh token might actually be too old, and it might be before I extended the timeout. Oh, it worked. Okay, we have a new token. Awesome. Okay, so here it's hitting the read endpoint. I really don't want to hit the read endpoint. What I want to do is I want to hit the feeds endpoint. So let's go ahead and copy this. So let's duplicate that, and so first of all, we're going to get the feeds. So let's hit the feeds endpoint, and we can see that the body that we're sending is a specification starting at a particular blog site. Give me all the posts, and give me a few things about them. Yeah, if I were to, let's look at the read output of that same body, just so we can see that working. Cannot distribute to, okay, so I changed the distribution rules. Let's modify things a little bit. Get posts. Actually, I think this one might be more correct. Yeah, don't save that one. That doesn't work. Okay, so let's try this one. Okay, that one's local. Replicator as a service. That one is, wow, that must be a really old one. Oh, that's a mix of all sorts of different things. Sometimes it's got a hard-coded thing in there. Okay. All right, let's just go back to this one then. So, yeah, so here we were trying to get the posts, and we don't have the distribution rule set up for that. So let's modify this so that instead of posts, oh wait a minute, I think I know why the distribution rule wasn't set up, and that's because I have restore in there now. Is that true? Post deleted. Let's try that real quick. So where not exists, restored, blog post restored, such that restored deleted being a blog post deleted is equal to deleted. Unknown must appear on the left hand side. Yep. Restored. Okay. Next. Nice. Hey, fixed it on the fly. Okay, so these are the results that we get from the read endpoint. But what I want to do is pretend that I'm the client. I don't want the projections. I want the facts that led to those projections, so I can update my own cache. Run my own projections, thank you very much. So let's copy that. And yeah, paste that in here. And so now this is going to get feeds. So send that, the fact me, it's not been defined. Okay, I think, yeah, read, I can use the shorthand for me, but for feeds I actually need to provide a hash. So let me get the site hash. So I will do site is equal to hash of site. We'll call it site ID. Boom. Okay, so here is the hash of the site. Now let's come back in here and I'll let that be this hash. Okay. Can't distribute. User's not logged in. Oh. Why is the user not logged in? I have tokens. Okay. Well, let me see if one of these tokens works. Okay, I'll just log in with this one. Get new access token. Okay, it's got the browser going on over here. So I'll do this off screen just in case it flashes. I know this is riveting content. Okay, and then get my Apple ID password. And then it's going to do two-factor auth. Hey. Yes, that is me. And here is the two-factor auth. And I trust the browser. And continue. There it is. Proceed. Okay, we have a token. Now, give me the feeds. Yay! All right, we have the feeds. So, that specification gave me back 5 feeds. If we take a look at the body, we can figure out what those feeds are. The first one is going to be the positive. That's just give me the post where there does not exist a delete. And then it stops. And then the next one is, I think it's going to dive in now one level deeper. And it's going to say, okay, give me the post and the deleted where there does not exist a restored. And stops there. So that's going to tell you about new posts. This is going to tell you about the deletions. And then finally, this one is going to tell you about the restores. And then we've got 2 more that are, okay, so given those posts that were never deleted, tell me about the titles, and then tell me about the next. Should there be, I think there should be 7 here, not 5. Okay, I'm going to have to go back and check this algorithm against the book, because the book actually predicts 7. I even make a note of that in the book and say, you know, most people wouldn't predict 7, but this produces 7. Yeah, I think I'm missing the restore name and the restore next. But we'll work with this. So I've got the feeds for that specification. And now I want to take a look at the contents of those feeds. So let's copy one here. And I'm going to duplicate this. And I'm going to get just a feed. So it's going to be feeds / and then the feed ID. This is going to be a get, so we no longer have a body. We're just getting from that feed. Same authorization. And so this should give me back the, oh, the error message again. User not logged in. I thought we just did this. Okay. I probably have this authorization on each request and not inherited from the top. Yeah, that's probably what's happening. Okay. Should be able to run through this again real quick. Yep, it's still me. Please proceed. Here's a new token just for you. Okay, so now we have the contents of the feed. That's not a very exciting one. Doesn't have any facts in it. Which is really odd because this told me that I should have some results. Yeah. Okay. Well, that's probably going to lead to a really short demo. We've got the bear token. The accept header is accept anything, and it's giving me back JSON. Let me try. I want to tell it that I only accept JSON. Oh, but I can't edit that here. Yeah, well, here was the content type JSON. I'm curious about two things now. So the first thing that I'm curious about is why it didn't give me back the new content type that I deployed if it says it accepts anything, and I check for that new content type first. And then I'm also curious why it gives me back no fact references. Well, the thing that it was supposed to do right here is it was supposed to give me back a bunch of fact references in JSON, and then I was going to go on to load so that I could load one of those fact references. Let's see if we can skip to load by just using the ID of the post. Let's do that. Okay. So I am going to, so we want this. So we want an object that has references and it has one fact reference in it. So let's duplicate that. And now instead of feeds, we're going to do load, not loaf, load. And I'm going to try to load post. And we'll have to redo the authorization. Unless one of these, this one here, use that token. Yeah. Maybe that token's good. Yeah, I think it is. Okay. Okay. So load, the body is not this. The body is JSON. It is references. Now we've got an array of objects with type like blog.post and hash. With that value. All right, is this going to do something? It says I'm unauthorized. I'm unauthorized to see that blog post. I don't believe that's true. Well, that is really interesting. Okay, maybe I got the type wrong. That's a fact reference. So the feeds, blog posts, yeah. So that's the load, blog post. Yeah, that is curious. This ID, okay, wait a minute. I think I made a mistake here. Get posts. So this is going to give me back the post. It's going to give me the ID, the hash of the post. When I'm trying to read. V has not been defined. That's because you don't have a good token. And this is the one that has the... Where did that go? Okay. One of these days I'll figure this out. So I want this not exists in here. Send that, distribute, okay. So now I've got this ID. This is the ID of a post. So that's the hash of a post. Blog.post. So did I copy that correctly into load? It looks like I did. Let's just double check. Yeah. And it says no. Okay. Well, yep, that definitely is your typical demo for a Thursday morning stream.
Murphy.
Yeah. But the thing that I did get working is that I could return that either as a JSON structure as it is now, or I could return that as a fact graph. So that fact graph, in fact, I did post in the general channel. I posted the result that I originally got, and so that was just straight off my machine.
Okay, I see.
So that first bit, that dash 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 0, that was something that I was adding as sort of a preemptive way to get to the feed thing, and then I realized that's not sufficient, and it's not necessary for load anyway, so I took it out for load. And then yeah, we've got a fact with its predecessors, so that's the empty collection and its fields, and so that Janaga user is ID 0 or index 0. Then we've got the blog site with the creator being index 0, and then another blog site. So what that is not showing, there we go. What that is not showing is that when you're authorized, when you're authenticated, then now you can participate with signed facts. So it's going to run the authorization distribution rules. It's going to end up signing things, and so the signatures are going to come down as well. So now you've got the public key of the user that signed them, the signature, and it's all part of that same protocol. And that's what I was hoping to be able to demonstrate here. Of course, I didn't try it out. Why would I do that? But yeah, the replicator as a service should now be returning those fact trees with signatures, and that way, a a client doesn't have to be just a mobile application that trusts whatever the replicator says. The client could participate in that authorization and distribution. And it could get further away from the key store that originally signed the fact. It says, well, I know the public key and I know the signature, I can validate it. And so that's what's going to enable all of this replicator to replicator communication. So while I was changing the format, did that too. And I decided to do it all through the HTTP accept headers. So if the content type is just application JSON, then you're basically saying, yeah, anything in curly braces is fine. It's application JSON. No, really. What I want is this specific format. So so now I'm using the accept headers to say, and the content type headers to say, I'm sending you a fact graph. I'm expecting a fact graph. And that allows me to have the replicator work with either version of the client. So I don't have to say, right, make sure this you've updated your client code in order to use this replicator. Either one will accept either one, and they'll just negotiate the way that HTTP was intended to negotiate.
That's nice progress.
Mm-hmm. Yeah, so maybe next week I'll try this out before I get on the stream, and I can show you that working. And I also, by that time, expect to have the .NET client working with this protocol. So, in fact, if I can get the JavaScript client working with this protocol too, then we can see this happening inside of the browser in the Terrible Chat app, and so that will then set us up. First of all, that'll unblock my my team. They're designing their model in order to minimize the amount of back and forth. And I was like, the model shouldn't be. You shouldn't design the protocol into the model. You should just design the domain. And so if I can get them unblocked, let them redesign their model to really just talk about the domain, then they can make a lot more progress. Then I can get back to the JavaScript client, get that one up to speed, and then we can talk about feeds and how we can fix those. So stay tuned for that one. Yeah, I think I'm basically taking your idea about let's use the bookmark to represent the Merkle tree, what the client already knows. I'm taking that just one step removed. So it's not the bookmark, but it is something else that tells you that you exchange in a very similar way. But I will tell you all about that next time.
But so your team is making progress with the application then?
Yes. So they have not yet exercised the authentication stuff. So they're still testing, unit testing with a local database, and testing with a replicator, just using Janaga Server, just the Node application, all without authorization turned on. And it shows in the model because the model doesn't have the necessary things to replicate or to authorize for the very first time. So when they do turn on authorization, they're going to have to add one more thing to the model and make that work. But they didn't want to have to reason through that. We saw right here, having distribution rules is a real bummer. If it's just open, then you don't run into the problems that we just ran into here. But yeah, you have to lock things down.
Yeah, but to start and to develop their model, it's a good way to have the security out of the way.
Yeah.
And they can add it afterwards.
Yep. But Yeah, I've struggled between the two forces of security first, shift left, and then
Mm,
the other force being it should be really easy to learn. Things should just work. Security is about, especially shift left security, is about things just not working. You have to explicitly make this one thing work, and then that's the only thing that works. Um,
mm,
that's that's security. Um, so struggling between those two forces, I decided, okay, if you don't configure security at all, it's wide open, and you can make things just work. As soon as you configure anything security related, then it's now completely locked down, and you have to open things back up one at a time,
mm.
and be very explicit about what you open up. Even to the point, as we saw here, of if you have another condition um, inside of your specification, a condition that wasn't in the distribution rule, it says, nope, that's not the right specification. I'm not going to allow that. Um, and that's because you could actually, if I did allow that, then you could provide a slightly different specification that could reveal more information than the original one did. And said, nope, that's the whole point. Distribution rules are saying only this information, no other, nothing else.
I saw a message coming in, I think, from GitHub. If I remember well, it's probably one of the people on your team who
Ah,
was asking to have, if I remember well, facts stored locally,
right.
which are not replicated, um,
Yes,
probably
yes.
for some local configuration data or something.
Yeah. Yeah, that's going to be a pretty exciting feature. I currently do have in the JavaScript version query local. So
Mm,
so that's a method that will run a specification just like query. It'll run the specification, give the results, and stop. It's not setting up an observer like watch or subscribe. Um, but query local will run the specification only against the local store and give you the results. Never try to connect to the replicator. Versus the
mm,
regular query will first connect to the replicator to fetch anything new that would affect that query, and then run the query locally and give you back the results. Um, so query is not offline first. Watch is offline first. And so my original thought was that for an application, you're going to be using watch all over the place, so you can be offline first. But there are a few places where you do actually need to just get a result so that you can move on to the next thing. So for those cases, it made sense to be able to do a local query. Um, so yeah, we talked through that use case, but then he wants to be able to save facts just locally, because while we're still working on stuff, we just want to save it locally, and then when the user takes a particular action, then it uploads everything. So that action would create a successor, and that successor would
mm.
um, have its transitive closure pull everything up to the replicator. But meanwhile, you've just saved all of those successors or all of those predecessors locally until that happened. Um,
Yeah.
so, so yeah, we're going to have a local version of the fact method as well. Um,
Yeah. And I still got. I read it very quickly, but
mm-hmm.
apparently I understood it wrong.
Ah,
Uh,
yeah,
I thought it was about facts which were not at all replicated, which stayed locally.
yeah, yeah,
But so
yeah. That's not what he wants it for. It could be used for that, but it wouldn't guarantee that they would never get
mm,
replicated, because if they're part of a transitive closure, then they would.
mm,
Um, so yeah, yeah there may be um, there may be a use case for the one that you're talking about, in which case we'll have to come up with a good name for it. But yeah, um, maybe by next week we'll have the local methods all set up. But if not, then the week after that.
mm.
But yeah, I think next week talking about feed optimization is going to be plenty to cover.
Okay. Good. You're sending off the script to the editor or not yet?
Yes, I'll be sending that off very soon. So,
Okay.
yep, we're gonna make that that final change of let's refer to immutablearchitecture.com. I'll take your additional suggestions as well. Get that sent off, and then we'll be on to the copy editing.
So further suggestions are not useful anymore, or are they?
Right. Yeah. So I've already finalized chapters 9 and 10. I think those were the ones that you did not do. So, but
For the old ones, but okay.
But if you
They
if you
should
still make notes and send them my way, then yeah.
for the next edition.
Uh-huh.
No, but I think these chapters they should be all right because they were already proven.
Yeah.
Okay, then see each other next week, I think.
Yes, indeed.
And that's another time change because this weekend we are changing to summer time. So then we will be back at. Now we started at 2 p.m. We will be back at 3 p.m. starting time. Yeah, the world is complicated.
Yes, it is.
Okay, Michael. See you next week.
All right.
Bye-bye.
See you, Jan. Bye.